So, welcome everybody. So I'm going to be talking to you today about continuous delivery of secure cloud environments. So just really quickly, a quick plug from our side. There's a conference happening in Manchester on 5th of July, which is free for people who are interested in microservices. So if you're interested, feel free to please go and get your tickets and go to that. Just a little bit about me and really a quick bit about OpenCredo. So I'm a lead consultant here at OpenCredo. We basically specialize in working with companies who are looking to sort of embrace some of the sort of leading tech out there and need some help in order to sort of embrace that and deal with some of the problems that they come about. At the moment, we do a lot of work in the cloud space and the DevOps space, and we're also doing quite a lot of work in containers, things like Kubernetes and the like. I happen to be the author of, or co-author of the book Neo4j in Action, and that's my Twitter handle in case you want to tweet about this talk. So let's get on to the actual talk. And and I need to say we're hiring, so if anybody wants to come. So the agenda for this talk is going to be, first of all, we're going to have a look at what the problem is that we're trying to sort of actually solve here. Then we're going to have a look at what are the options out there to do this stuff already. And then we're going to have a look at how we've gone about doing that on one of the projects that I'm working on, but also in general how we tend to do this with some of our clients. So I'm working with a UK government department on a cloud automation project at present, and some of what I will talk to you about today is based on that, as well as general experience. So first of all, what is the actual problem that we're trying to solve here? So the cloud market has changed quite a lot recently. It started off where there was one sort of bulk player, which was Amazon. Now you have the likes of Google and Azure and various others. And although many organizations have managed to successfully embrace and take advantage of cloud computing, for a lot of traditional enterprises, and the government is included in this, they've found it quite hard and quite difficult. With different clouds, you've got completely different ways of doing things and different opportunities out there. And you also have developers doing things one way in this cloud and completely different in another cloud. And from a sort of traditional IT operations perspective, it's very unclear to them how have these environments actually been created in the cloud. Are they secure, or do they adhere to the kind of practices that we traditionally want to see? So instead of kind of abandoning going to cloud completely, what they've decided to do is, if we can at least get to the point where we can be confident about the way these environments have been created in the cloud, are they secure, do they adhere to some of the practices that we're after, they're prepared to start embracing it. So they want a process that will allow this to be able to take advantage more efficiently. So when a development team comes along and they say, I would like an environment in a cloud, rather than arbitrarily going and spinning a few machines up and allowing them to experiment, what they want is a process for them to be able to create a repeatable, secure environment in that cloud provider. But besides this sort of basic premise, they potentially want to be able to recreate that same environment either in a different cloud provider or be able to start in a different cloud provider altogether. And the reasons for this can vary. It can be sort of financial or strategic. It could also be sort of technical. There may be better latency guarantees in one cloud compared to another. But it can also be workload driven. So some companies are quite happy to run certain development workloads in the public cloud, but they want to run other workloads in a private data center or a different cloud, which offers different guarantees. But whatever the reason, avoiding vendor lock-in is a very hot topic at the moment. So the summary of really what we're trying to do is we're trying to say, how can we go about creating a secure, isolated environment for a developer to go and do what they need to do for their various tasks. And we want to do this from two perspectives. From the developer, we want to make it quick and easy for them to get these environments up there. So in a lot of these organizations, it's not unheard of for it to take weeks or months for them to get their infrastructure. But at the same time, we need to do it in a way that management will be happy that these environments have been created in a way that adheres to their various requirements. So for the rest of this talk, I'm going to take an example of one of these environments that we want to create in the cloud, and then we're going to have a look at how that happens. So let's say there's a team one, and they've been tasked with converting a monolithic application into a microservice-based one. And the architecture's been set. They're going to use Kubernetes. and maybe they're not quite happy with this persistent storage thing yet, so they're going to have an actual Postgres database in there as well, not a containerized one. And this team now need one of these environments that they can go and do their work and do the conversions. So as far as they're concerned, the sort of key functional components that they want in the environment is that they need a Kubernetes cluster and they need a Postgres database to have the information that they want in there. But once the fundamentals have been established of what this environment looks like, they just want to say, I want one of these environments. By the way, I want 3 Kubernetes slaves, and this is the SSH key I expect to be able to log onto my boxes with. Go and make me one of these. So if team 1 is the only team wanting to do that, that would be fine. But there's also potentially other teams out there who want different environments created. Maybe they want a tooling environment to do Jenkins things, or there's a different kind of setup that they're trying to achieve. And there's some functions that are common across these environments, things like DNS service. So that's handy to have irrespective of the type of environment that you're creating. From our perspective, the environments that we stand up are also completely isolated. So you can't get to them from the outside. You need a VPN connection to be able to get in and then to be able to do whatever you need to do. So we want to bring along our own VPN solution and DNS across all of the environments that ultimately get spun up in the cloud. So at the end of the day, you kind of land up with this concept of an environment contract, which is something that kind of defines this is the environment that I want to spin up in whatever cloud. And it has a sort of configurable IaaS layout, the agreed software that you potentially want installed on the boxes, and yes, and that's about it. So what are the options out there to do this already? So if you want to go and you want to create these environments in different cloud providers, is there some software that can do this already for you? And as soon as anybody starts talking about multiple or hybrid clouds, you are inevitably going to run into some products called the cloud management platform products. These are various commercial or sort of open source offerings that claim to provide you with a single pane of glass that will allow you to do everything in different cloud providers. You can do your IaaS provisioning, you can do your configuration management, you can do monitoring, you can do everything from this one tool. And some are better than others, but they all tend to suffer from the same thing, and that's that they try to be all things to all people, and they land up mastering none of the individual bits very well. So, and they're also often playing catch up. So if you get one of these tools, you know, they might support these cloud providers, but if another one comes along, it's tough luck for you. You can't use it until they start supporting it. So instead of opting for a one-size-fits-all solution, what we really said is, can we rather get a toolbox of tools together that will allow us to achieve the same result, but by bringing the right tool for the job? So you can say, well, that sounds fair enough, but you also can't arbitrarily come and get a whole bunch of tools together and throw them together and hope that you're going to get a cohesive solution out at the end. You need to think about how you're going to bring these tools together in order to achieve your end result. So for us, the way that we achieve this is by following a set of principles when we spin up these environments. And they can, these basically inform the tools that we choose, but also the way that we choose to integrate them. And this way, provided we stick to our principles, we potentially have the opportunity to change the tools that we're using, but not sort of sacrifice the ultimate sort of end goal that we're trying to achieve. So the principles that we follow can be described by an ASAP acronym. So the first thing is that we want to automate absolutely everything. So the goal is to have fast, repeatable environments, and we don't want any humans in the loop. They just slow things down, and manual configuration of any aspect of the system is going to be error-prone. We also have the goal of creating flexible environments, both from being able to be created in different cloud providers, but also if there's different tools that we want to use, we potentially want to be able to swap those tools out. And if you're going to try and do these kind of things, we feel quite strongly you must separate your configuration from your code so that you can swap these areas out independently. And in order to automate things, you need to have APIs. So both in the tooling area as well as the actual cloud providers. Some cloud providers out there are not really cloud providers. You have to go to their portal and click on things. That really doesn't work in this kind of setup. You need to have an API in order to do this stuff. And although we don't discount commercial tools at all, our preference is really for modular open source tooling. So there's two broad areas to what I've described. There's this sort of self-service functionality where the developers will come and they will choose the environments that they want, fill in some information and say, this is the Kubernetes environment that I want. So we're not going to look at that. We're going to assume all of that is done. Now we're going to sort of dive under the hood and look at the technologies that are ultimately used to create these environments. So the high-level overview of the building blocks that we use and that we're going to cover are these. So the first one is Packer. So Packer is a tool from HashiCorp, the guys that make Vagrant. And we use this to create consistent cloud images in the different cloud providers that we're targeting. So this ensures we have a common base setup that we can start from. Once we've got that, we then use another tool from HashiCorp called Terraform. And we use Terraform to create all of the macro level infrastructure for us. So this is things like your networks and your security groups and stuff like that. And they're based on this common image that we created with Packer. We then have a bootstrap mechanism which we hook into something called Cloud Init on the boxes, which allows us to hook into the bootstrap mechanism of the individual VMs. And essentially all that does is it offloads to a configuration management tool, something like Puppet or Ansible, which will then convert these vanilla boxes into something more substantial. So in our particular example, it will convert the boxes to be Kubernetes nodes and masters, as well as databases and whatever else we need. And across all of this, we have to make sure that things are done in a secure way in terms of the way we handle secrets and various other aspects. And so we use another tool from HashiCorp called Vault in order to do this side of things. So you might look at this and say, this is a mutable infrastructure. So I'm not sure if you guys are aware of the difference between mutable and immutable infrastructure. But if you think about a lot of the organizations out there, this is a pattern that they're more used to compared to an immutable infrastructure where you need to recreate every single machine from scratch, even if you make one change in the application. So a lot of the time there are legacy environments which are being created, and that means that they'll have to bring existing setups into the cloud which may have stateful architectures, and it's a lot harder for them to deal with that if you have an immutable setup. So in our case, it's not actually that bad because we're using Kubernetes. So although your infrastructure is mutable, you have something like Puppet, which is configuring the boxes. Once Kubernetes is there, from an application perspective, you can have an immutable app deployment moving forward. So how do all of these pieces actually fit together? So let's dive into these four areas and have a look. So the first one, as I said, is how do we go about doing the automated image creation. I'm not going to spend a hang of a lot of time on here because I want to spend a bit more time in the other areas. But like I said before, we use Packer. If you have a CentOS 7 starting image, if you're going to start in Amazon, that image is going to potentially be quite different to one that's in Azure or in your internal data center. So if you want a level playing field, you need to have a tool that is able to start from a common base, something like an ISO, and then install all of the software that you want as a starting point. And Packer is the tool that we use to do that. So we have a single definition and we say, this is what I expect the starting point of a CentOS 7 or a RHEL image to look like in all of the different cloud providers, and we upload the images. So that's the tool that we use in order to do that. The second and the challenge that we're going to have a look at more in detail is how we do the automated infrastructure provisioning. So in our example environment, we have our sort of conversion environment. And if you want to go and create this, depending on whether you do it in Azure or Amazon or OpenStack, although conceptually they have very similar concepts, things like networks and security groups, the APIs are fundamentally different and they are just incompatible. And in fact, you even have completely different offerings in one cloud provider compared to another. And the lesson here is that there is no such thing as a common cloud API. It does not exist. There are libraries out there that will try and abstract this for you, things like JLib and libcloud, but all they ultimately land up doing is giving you the lowest common denominator across all of the clouds. And we really didn't want this. What we wanted to do is say if there's some special feature in a cloud, we want to potentially be able to use it and not be constrained by that. So we want a tool in this space that will allow us to do that. And the tool that we chose is, as I said, Terraform from HashiCorp. So for those of you who, has anybody used Terraform here? Yeah, so sort of, okay. So essentially Terraform is a tool that allows you to create, manage and manipulate infrastructure resources in different cloud providers. So the way it works is that you define a couple of files, and these have got resources which define your infrastructure that you're trying to create in the cloud provider. You then have a command line tool and you point it at this definition and you say go and make this happen in the cloud provider, and that's essentially what it does. Out of the box, Terraform supports all of the major cloud providers and also some of the smaller ones, some OpenStack based ones. And the nice thing with Terraform is that it provides us with a common paradigm and a way to create infrastructure in a cloud provider irrespective of which one it is. So the nice thing with this is that we don't need to resort to custom tools. So for example, if you were only in Amazon, you would use something like CloudFormation. If you were in OpenStack, you would use something like Heat, and they're very specific to the clouds that you're dealing with. With Terraform, you can use Terraform essentially in order to do all of this. And the nice thing is that it also has a pluggable API. So this comes in very handy when you come across a cloud that's not supported. So we had a situation where we needed to integrate with a vCloud-based cloud provider, and there was no support for it in Terraform. But because it has a pluggable provider API, we actually wrote the API, so we wrote the provider ourselves and ended up contributing it back to HashiCorp, and it's now part of their official product. So the fact that one of our principles is that we want a tool that's got APIs and drivable by APIs mean that when circumstances come along that don't quite fit the tooling, we can write and adapt for it. So this is what Terraform looks like. It's a declarative sort of DSL language. This is something called HCL. You can also do it in JSON, but the DSL is custom to HashiCorp, but they try to find a language that allows you to find a sort of a balance between being human readable, editable, and also machine readable. So the way that it works is that each resource that you want to control in the cloud provider, you declare in your entities here. And this is with the resource keyword. And then this is an example in OpenStack. You can see the top entry is we're creating a compute instance. So this is a virtual machine, essentially. And then in the bottom, we've got something called a floating IP. So we want to get a floating IP out of a pool of IPs and actually assign that to our OpenVPN box. So the first part of the resource definition tells you this is for an OpenStack-based cloud. And the second bit tells you the type of the resource that you're going to be creating in the target cloud provider. You also then give these entities an alias, and what we'll see a little bit later is it allows you to reference the different resources that you've created and actually tie them together, so you can create dependencies and all manner of interesting things. So that was for an OpenStack-based cloud. What does it look like if you want to do the same thing in Amazon? So as you can see, it's sort of the same, but it's a little bit different because Amazon's API is not going to be the same as OpenStack. So here we have an Amazon instance with different variables. We don't have this concept of a floating IP. In this case, we have a subnet with a DMZ, which we are using in order to expose the OpenVPN box. But the end result, irrespective of whether I'm trying to do this in OpenStack or Amazon, is that I'll end up getting an OpenVPN box with a public IP that I can use to get into my environment. So that's great, but Terraform allows you to hook things together that are not just the cloud infrastructure resources. It supports a variety of other providers. So in theory, there's support for things like PaaSes, like Heroku. So you can create stuff in Heroku. There are DNS Simple and various other sort of DNS providers that you can integrate with as well. Mailgun, it's not restricted just to compute. And for us, that proved quite useful because we needed to combine infrastructure from different cloud providers. So if you take, for example, Route 53 is Amazon's way of creating DNS entries. If we were creating our infrastructure in Amazon, we'd have all of the infrastructure based in Amazon, the Route 53 entry, as well as all of our compute resource. But if we wanted to do that in OpenStack, we're now spanning 2 different cloud providers. We've got some resources in OpenStack and half of it in Amazon. The nice thing with Terraform is that you can do this, and you can combine infrastructure from different cloud providers in your one Terraform file. And if you wanted to, you could even do both of them at the same time. So here's the example of the Route 53 record. Again, in this case, it could have been DNS Simple or some other cloud provider. But again, it's the same syntax, and you basically just define the resources. So another thing that Terraform allows you to do is have variables and be able to tie your resources together. So this is quite handy for us because one of our principles is that we want to separate our configuration from our code so that we can define these entities and create them in different places. So Terraform allows you to define the variables, and we'll have the users providing some of that. So for example, they might have said, I would like 3 Kubernetes clusters. We can pass that in as a variable here and then allow Terraform to create what needs to be done. Within the DSL, as I said before, these resources can actually refer to each other. And Terraform is clever enough to understand these dependencies when you do them in the code, and it will make sure that it creates the resources in the different cloud providers in the right order for you. So here we have an example where we have, this is for OpenStack. So we have a pool of IPs, and we have this floating IP in the middle. And essentially what we want to do is we want to obtain an address from that, and then we want to say, I want to assign that address to my OpenVPN box so that I can make sure that that's the IP that it comes up on. And I also want to send it into the Route 53 record so that my DNS is pointing at the right place. And again, Terraform allows you to do this, and it will make sure that it creates that first and then the other 2 afterwards. So the other thing that it can do is things like user-controlled resource scaling. So if you've used auto-scaling in Amazon before, you can tell Amazon, I want to create a certain amount of machines, and there always needs to be 3 of them. Terraform allows you to control this manually if you want to. So in our example, we had our Kubernetes cluster, which had a master with 3 nodes. So we can configure this particular setup, and we can say, I want to configure at the point in time how many nodes I want. So we define that as a variable, and maybe we start with 3 of them. If we decide, well, our load is too big, I need 10 of them now, you just change the variable, get Terraform to reapply itself, and it will create 10 machines for you in the cloud provider. So it allows you to manually control this. And one of the other things that it can do is it has a sort of the ability to define this as modules. So you can take these individual entities and create modules and come up with a more sort of programmatic way of constructing these entities. So the example here is that we had a DNS entry module before, and here we have a module which allows you to create a management layer in our cloud, where we say, I'm going to create the OpenVPN box in there, but I have a separate module which does DNS down the bottom. And I want to take the output of the IP address from the VPN box and pass it into my module for DNS and have the infrastructure created. So that's great. But one of the key selling points, I think, as well, is that Terraform is not just for instance creation first time around. You can manage your infrastructure going forward. So as I said before, you define your entities in these various different files. And when you make a change to the file, you can ask Terraform to tell you what it's going to do. So you can say, I've changed from going from a small box to a medium box. Please, Terraform, go and apply my change. And it will say, oh, I see that you're trying to go from a small to a medium. In this cloud provider, it means I have to completely destroy the machine and recreate it. But maybe for some other entity, all I need to do is upgrade it. So it gives you this plan, it tells you what it's going to do, and then you decide, do I really want to go forward, yes or no? So you can really keep track of your infrastructure that way and have a controlled way of upgrading and destroying things. So the summary in this sort of section is that With Terraform, we've very much found a tool that adheres to our ASAP principles. We've managed to automate everything, managed to separate our code from our config. We've got an API-driven tool, and our preference for a modular open source tool has been adhered to. As I said, the key selling point allows us to combine infrastructure from different cloud providers, and we have a point where we have infrastructure as code now. So the entire creation of the machines, the networks, the security groups is all being codified for us. And as we said in the beginning, one of the things that we want to do is we want to make this process transparent so that management and people who are not so sure about how have these machines actually been created can literally go and audit it if they want to, and they can see how the security groups are laid out, the networks, everything, and say, yeah, I'm happy with that, we can move forward. So that's great. We've now got our sort of, we've automated that infrastructure and we've tied it together at a macro level. Now what we want to do is zoom into the actual boxes and install some software. So there's two aspects to this challenge. There's how do I do it the first time round and how do I do it sort of moving forward. We're really going to look at the initial bootstrap problem. So we made a very sort of conscious decision to decouple the initial bootstrapping process from the actual configuration management tool that does the heavy loading. John's going to talk about Puppet a little bit later, so that fits into the other side of the camp. But essentially what we want is when the machines come up, we're going to use some software called Cloud Init to hook into the bootstrap process, do a few minor tweaks, and then just hand off to the configuration management tool of choice in order to go and install the software. So there are lots of good tools out there, and I'm not going to go into any kind of wars as to which one is better. Rather, I'm going to focus on how this kind of all hangs together. So this is where we've been left off with Terraform. If you ignore this bit on the right just for the moment, we've got all of our infrastructure created in the cloud provider, got all of our networks and everything. Thanks to Packer, we've got images that have all got Cloud Init installed on them and waiting to boot up. So, do all of you know what Cloud Init is? Or anybody know what Cloud Init is? No? Okay. So Cloud Init is basically software that we bake into all of our images, which allows you to hook into the bootstrap process when a virtual machine actually comes up. It's open source and it works across cloud providers, so that's something obviously that we're quite interested in. And the way that it actually works is that it hooks into something called the cloud provider's metadata service. So whenever you go and create an instance in the cloud provider, you are able, when you boot up, to talk to this metadata service and ask for information about yourself, like what is my host IP and stuff like that. The other thing that you can do is you can pass in something called user data as part of the creation of your machine and say, when my machine comes up, please give me this piece of content I've given to you and execute it. And these scripts can be either bash scripts or YAML files, and that's essentially what we want to do is we want to create one of these scripts and pass it into the machine so that we can begin our bootstrap mechanism. So this is an example of what a cloud config script looks like. This happens to be a YAML definition. You can use just a normal bash script as well, but you can do some things like set your host name. But as I said before, the thing that we really want to do is we just want to bootstrap whatever the config management tool is in order to do the software installation. So that's great. How do we get this stuff into the actual instance? So we know that we've got Terraform as our tool for interacting with the cloud provider. And one of the things that Terraform allows you to do is to define something called a template. And you can then go and define your Cloud Init config, be it a bash script or a YAML file. And then when Terraform renders and it puts all the pieces together, you can associate it with your machine and say, pass this in, and when the metadata service asks for it, please give it the script and then start executing. So on boot, Cloud Init is essentially triggered, and it lands up running this automation script that we've just passed in. So the way that this works in our particular setup is that we have one box, which is this big box over here, which we use to act as an orchestrator. And that's going to have things like DNS and also our Puppet master installed on it. And its Cloud Init process will go something like this. It will do some basic setup, just in terms of getting its host name. And as part of the data that's passed into Cloud Init, we're going to pass in a one-time security token. And we use this token in order to talk to Vault, which is a service that I'm going to talk about a little bit later, which is where we store all of our secrets in. So we take this token, we connect to Vault and say, please give me some credentials to talk to my Git server. So we take those credentials, we go to our Git server, and we download all of the Puppet code that we want to start bootstrapping with. Once that gets downloaded, we initiate a Puppet run on ourselves, and that lands up installing a Puppet master on the box as well as the DNS capability. Once that happens, all of the other boxes essentially wait for the DNS to be ready. When they detect that, they get their own DNS. They also wait for the Puppet master to be ready, and once that's been detected, they ask for a Puppet run to be initiated. And essentially what happens then is you have this completely asynchronous bootstrap process where you have all of the software which you now wanted on your machines actually installed. So we were wanting our Kubernetes environment with our 3 nodes, and that's exactly what we've got at this particular point in time, and ready to go. So from the sort of automated instance management summary, we've got, as I said before, a completely asynchronous bootstrap process. So what I mean by that is when you tell the infrastructure to create itself, you don't have to wait until it's there and then go and make a separate configuration management run afterwards. It just detects the fact with Cloud Init that I'm ready, I need to start bootstrapping myself, and then the environment starts configuring things on the inside. By the time it's finished, you've got this completely self-contained, stood-up environment. Again, we have the same thing with Terraform. We had the infrastructure as code. Same thing here with all of the Puppet or whatever Ansible you've used to install on your boxes. People can audit that. They can completely see how it's been set up and make sure that they're happy with that. And again, we've adhered to all of our ASAP principles. Automated everything, separated our configuration from code, and all the various other bits and bobs as well. So one of the things that we did do in one of our environments, which was quite interesting, was that one of the clients said, I want to move from Ansible to Puppet. And in that particular environment, it was possible to do that because everything had been separated out. We could swap Ansible for Puppet. It wasn't a completely seamless transition, I will say that, but we didn't have to worry, oh, my networks are now going to be messed up, etc., because that's been handled by a completely different tool. We only swapped out the configuration management part. Yeah, and that's it for that bit. So, on to the final challenge, which is how do you now go about securing all of this stuff? So, security is a massive topic, and we obviously aren't going to be able to sort of cover all of it. But one of the first things to say is with something like Terraform, you have, as I said before, all of the ability to define your security groups, all codified. So from that perspective, completely auditable, and you can see exactly what's going on. We also have everything's completely self-contained, so nobody can get into these environments unless they have an open VPN connection. So from that perspective, it's also quite secure. But an area which cuts across all of the different tools that we've been speaking about now is secrets management. And this comes in the form of how do I get my secrets about the cloud provider that I actually want to connect to when I'm running Terraform. Once those machines are actually bootstrapping, how do I get secrets about what the database password's supposed to be and all of the information that I'm trying to install? How can I go about getting all of these different tools that we're using in the solution to have a cohesive secrets management setup? And the key lesson here is just don't roll your own. Unless you seriously know what you're doing, and if you think you do, you still probably don't. Don't try and do this yourself. Security is really hard, and what you really want to do is try and leverage a tool or tools out there that you can trust in this area. So the tool that we chose to use in this area is another HashiCorp tool, something called Vault. Very new, we're still kind of trialing it out for things, but it's working out pretty well for us at the moment. And it's essentially a tool for managing any secrets that you want or any sensitive content that you're trying to use as part of your process. It fits in really well with our ethos because it's a dedicated tool that exposes itself through an API, and its sole goal is to store sensitive data and allow you to retrieve that information in a controlled way. So it does more than just acting like a secure database. It allows you to have pluggable backends. So this means if you want your information to be stored on file, you can store it on file. If you want to store it in a backend database and encrypt it there, you can do that. So it's quite flexible in terms of the storage. It also has policies which can define which tools and which people have got access to which part of the data. It's got audit logs so that you can see what's going on, and in the event of a compromise, you can go and have a look at exactly what's happened. All the kinds of things that enterprises and just good practice is generally really interested in making sure that things are done well. So, in our particular setup, when I told you to ignore that bit on the side, I was talking about Vault. And we run basically a centralized Vault service that we then configure all of the different tools in our setup to be able to talk to. Now what we could have done is we could have said, well, these different tools have got their own way of dealing with things. So if we're using Puppet, Puppet's got something like encrypted hero. Chef's got something called encrypted data bags. And we could have used that. But what would have happened is we would have had secret sprawl all over the show and different secrets in different tools. And we really didn't want that, so we want to centralize it in one place. From a sort of integration effort perspective, different tools are more easier to integrate than others. So ironically, we found that Terraform, which is a HashiCorp tool, does not have native Vault integration, which is a little bit surprising to me. Apparently it's coming. So we needed to do our own over there. But again, because one of our principles is all of the tools must have an API, we could do that. So it wasn't a problem for us. Things like Puppet, there is a Ruby gem out there already, which allows you to literally connect into Vault and obtain your secrets and do the bootstrapping that way. So how does this work? So there is a one-time process where when you set Vault up, you've got to go through an initialization and unsealing process. And that basically sets the Vault database up and says, right, I'm going to be ready for you to use. And the way this works is a little bit like when there's a missile strike. So you see in the movies where you've got the three generals and they go into a room and they say, you have to put two of your keys in at the same time and turn them, and then the missiles will launch. It's exactly the same principle, something called Sharma's secret sharing, which is used to initialize and unseal Vault. So when you set Vault up for the first time, you'll say, oh, how many keys do you want Vault to be created with? So you'll say, in this case, I want 3, and I want at least 2 of them to be able to be used in order to unseal. So here we can see the process of the first unseal happening. So we can say, I'm going to take that first key, and I'm going to unseal Vault. And it says, oh, great, I see you've done 1, you've still got 1 to go. These keys would typically be distributed amongst like 3 different people. So at least one of the other 2 will need to come along with the key and put it in order to unseal Vault. So there we say the 3rd key has come along, we've unsealed it, and it says, great, I've got the 2 out of the 3 that I use. Vault is now up and ready for use. If in the event of a compromise, you can completely shut it down, seal it, and nobody will be able to get access to the secrets. And this is just a really good way of actually initializing things. So we've got all our secrets. Well, we don't know our secrets yet. We have Vault, it's initialized, and it's ready for use. Now we need a combination of people and tools to be able to populate the secrets in the Vault database for the environments that are actually going to get spun up. So they can do this basically by creating a specific mount area in Vault and then writing the passwords into there, either manually or through some kind of tooling. So here we have an example of what this looks like if you were to do it on the command line. So you can say to Vault, for team 1, which is the team that we want to create our environment for, go and create me a mount, and you can list them. You can then say, go and write some cloud provider password into the team 1 area and then read it out again. So this gets you to the point where you've got the actual secrets now installed in Vault, and you're now ready that if somebody asks for one of these environments to be spun up, that it can go and get the secrets it needs in order to do the bootstrapping. So essentially what will happen at this point in time is that when the people come along to do this, they will need to get a token, and that token will say, for team 1, you can only see this part of the secrets database, and we'll allow you to get this information in order to do your bootstrapping. So they acquire that token, and then that gets automatically configured in the various different tools, and they use that in order to do, in order to get their secrets. So this is just an example of what it looks like, a bootstrap sort of policy. So you could say, create me a policy and say for team 1, you should only be able to read stuff that's defined under team 1's area, and create this policy. Then when you come along, when a token is created, you create it with a particular policy. When you authenticate with the token that gives you, example where we try to read something from team 1's area and that's successful, but when we try to write it, it will say, no, I'm sorry, that's not part of the policy, you're not allowed to do that. So you can completely control which parts of the tools are able to get access and view and write secrets. So the summary on the sort of security side is that we really just kind of scrape the surface. There's a hang of a lot of stuff that we can sort of talk about here, but from the sort of secrets management perspective, having a single place where you can do central key secret management is very handy. It's a lot easier to roll your passwords, and in the event of a compromise, shut things down and manage things a lot easier. It gives you quite granular access control, so it's easy to configure. And the key thing is just do not roll your own. Enterprises are much happier when they know there's a tool that's just dedicated to doing secrets, and not developers haven't gone around putting things all over the show and trying to write their own crypto and stuff. It just doesn't work. So the conclusion is that what we're really after is creating these fast, repeatable, secure environments which were capable of running in different cloud providers. And if you have a look at the definition of continuous delivery from Jez Humble, it says, continuous delivery is the ability to get changes of all types, which includes infrastructure, including new features and configuration changes, bug fixes, experiments into production or into the hands of users safely and quickly and in a sustainable way. So in order to do that, you need to automate everything. And as I've said before, we want to learn some of the lessons from the software side of things and have everything codified. This is where the infrastructure as code comes in. So, not every problem needs a hammer. Use the right tool for the job. There's a lot of different areas that we've covered here, but try and use the right tool for the job, and if you segment things, it will also allow you to adapt a bit more easier. So, cloud is changing constantly. There's a lot of different clouds coming out there. There's a lot of cool tools coming out there, and you want to be able to adapt. So make sure that if you are trying to do these kinds of things, that you get hold of tools and use principles and APIs that will allow you to adapt in this area. And finally, be true to your principles, but be flexible in your approach. If you stick to your principles, you'll be able to swap out certain things, but it'll still allow you to move forward with your ultimate end goal. And with that, that's it really. So thank you, and I don't know if there's any questions.
Isn't Vault now your single point of failure?
So you can run Vault in an HA setup. So you don't have to have one instance. You can run it in an HA setup. So, yep. So not necessarily.
Are you running a Vault per environment or a central Vault for everything, or is that still a kind of decision point?
There's all different setups are done differently. So for some there's a single Vault setup. In others you can actually spin up your own Vault for different setups, and it really depends what the different teams and environments are looking for.
You mentioned the lowest common denominator problem with the building and abstraction of the things that the cloud providers do, and the pluggable nature of Terraform that got around that a little bit. But once you get up to the software you're actually deploying on these clouds, have you seen people having to introduce adaptation at the kind of application layer around things like how you deal with persistent disk snapshots, how you deal with metadata service for, I know an example is on Google Cloud using Minto auth tokens, things like that just look different from the application's point of view. And have you ended up building your own abstractions to deal with those things?
So yes and no. You inevitably build some kind of abstractions. I think there's always going to be certain things that are going to be different in clouds, and you're never going to get away from that. So one of the examples that I can use is, you know, if as a general concept you want relational capability, you can say, if I'm in Amazon, I want to use RDS. But actually, if I'm in some other cloud provider that doesn't give me database as a service, I'm going to spin a box up and actually set it up that way. So they're completely different, and you'd have to actually deal with them differently. So there is a level of you have to normalize somewhere at some point, but then there will be some point where you're like, now I'm just consuming the service, so now it just looks like a database to me. But there is always a layer of having to adapt somewhere, and that will be evident in different areas within the stack at some point.
Have you got any kind of, have you used any kind of automated testing of the entire thing spun up across the different clouds? Yep. So you know that adaptation is working? Yep.
So all of our sort of environments, we have a daily build which can kind of run every day basically, because it takes a bit of time sometimes to do this. And we basically spin the entire thing up, wait for all the machines to be ready, and then we run a whole suite of automation tests on top of that. So that uses a variety of different tooling, things like service spec, as well as we actually just do Cucumber BDD style testing as well to make sure that certain things are set up, and ensure that the environments are configured in the way that we do. So we do have that, although it lands up costing quite a bit sometimes depending on how many things you need to test. So.
So how do you manage the Terraform status? Are you using console talking to the Terraform?
Terraform state file you're talking about?
Yeah.
Yep. So different setups do it differently. The one at the moment is that we actually store it still in an individual file, and this is something which I didn't talk about, and that then gets stored in a persistent storage, be it Git or a database. It really depends. But one of the things that you have to worry about when you're doing Terraform is that you may land up with secrets getting embedded into the Terraform state file, and this is something which can happen. So what we'll end up doing is we actually encrypt that file before we store it in the final storage. And we wrote another tool called TerraHelp, which is actually on the OpenCredo GitHub page if you go and have a look there, and that will allow you to do either inline encryption using Vault or just normal crypto in order to encrypt the file, and then you can store it, and then when you want to get the environment you just bring it down, decrypt it, and then do what you need to do. But you do have to be careful about getting secrets stored in there and exposing that, because that definitely happens.
Do you ever have to find the difference between creating the infrastructure with Terraform and then separately ongoing management of the infrastructure Terraform in terms of some clients when it's like things?
So I'm not sure if I fully understood the question, but in terms of this particular setup, the ongoing maintenance of software is done by something like Puppet. So once the infrastructure is set up, Puppet is then used to control the software on the box. So if you want to upgrade packages or whatever, you would use Puppet to do that. If you want to add new boxes and things like that, you'd still do that through Terraform. I don't know if did that answer your question or not quite?
Yeah, yes, well, I guess I'm not familiar enough with it to
okay.
kind of really get the picture in some ways, but sort of being through a number of situations where the initial creation of something differs in some ways to the ongoing management, even if you're using the same tool to do something.
So what we try to do is only create our infrastructure and manage it through Terraform. So you land up in a bit of a problem where you use Terraform to create some of your stuff, and then somebody goes in around the back on the console and they start playing around with things. It causes all manner of problems. Sometimes you just have to do that. Sometimes there's manual things that you need to do, and then you've got to do a bit of jiggery-pokery to sort stuff out. So that does inevitably happen, but part of, I suppose, the principles that we try to do is everything goes through Terraform, and only unless you're in dire straits and you really have to do something manual, do you try and sort it out that way. But Terraform generally allows you to do what you need to do. Having said that, there are some features in clouds that are not available yet through Terraform. So depending on what you're trying to do, there are then sometimes areas where you may need to do something else with a different tool, and then you have to be really careful about that and be very selective about making sure that they can still work together. I don't want to take up, I don't know, do you want to, one more? One last one.
Sorry, it's me again. Am I possibly a slightly controversial question because it's a more non-technical one.
Okay.
But when people come to you and say, I want to be able to run this workload across multiple accounts, is it generally a totally non-negotiable at all costs, we just have to do this or we can't do the project thing? Or do they ever look at and talk to you about what kind of overhead is involved, both in terms of initial setup and then ongoing maintenance, leakage of the adaptation through to the app, all those kind of things involved in being able to do that?
So I mean, not everybody wants to be able to run across multiple clouds. So in this particular case, the setup would allow you to do that, but quite often people are like, well, I'm only interested in one cloud, so let's choose that and go with it. So irrespective of whether you want one or multi, this process would work. But yes, it's horses for courses as a consultancy. There's a trade-off between you can do it a lot quicker if you just use native features for certain setups, but if you want to be more agnostic, you've got to put a lot more effort into it. There's time, testing, all manner of extra things involved in that. And it really comes down to what is most important to the client. Is it getting to market first and being able to take advantage of that? You're going to go down a different route. Or is it, I've been burned, I don't want to land up in this situation before, I want to have a few options to play with? Then you have a different set of considerations, and it just depends. It's the short answer.